Okay, this is going over the Unit 3 review. Number 1 asks us to find the axes of symmetry of this equation. So in Part A, to find the axes of symmetry, you're looking for the x value that is opposite inside here. And remember, it's a line, so you must write x equals. The opposite of positive 6 is negative 6. So axis of symmetry is x equals negative 6. Part B, finding the vertex. To find the vertex, you have to go opposite same. So the opposite of positive 6 is negative 6, and the same exact number we have is negative 2. And that's the vertex. All right, let's go ahead and take a look at number 2. Number 2 has quite a few different things going on there. So we have to take a look at this equation and find out what the domain is. Notice that for the domain, we're looking at the values that are possible for x. Well, this graph keeps moving to the left and it keeps going to the right. And so since it goes left and right, the domain is going to go from negative infinity to positive infinity. For Part B, it's asking us to state the range. The range value, well, it doesn't go up and down. It only starts at 0 before this whole graph moves upwards. So starting at 0 and including 0 up to infinity. Okay, Part C is stating the axis of symmetry. The axis of symmetry is the line that splits this parabola. That line right there is not just a number, it's an x equals value. And x happens to equal 0 at that point. And D is stating the vertex. Well, the vertex is the very bottom of this parabola, which happens to be 0, 0. All right, let's take a look at number 3. Number 3 is asking us to state the vertex and what happens if a is less than 0. Keeping in mind that this is your vertex form. So the vertex you can find right away, opposite same. And inside opposite is positive h and outside is k. And then Part B, what does it mean if a is less than 0? Well, if something is less than 0, it's got to be negative. So if a is negative, this parabola is going to go and turn downwards. The way we say that is that it reflects, and you can say across or about or in, but it reflects across the x-axis. Okay. All right, number 4. It's showing us a graph, and this graph models a rock that is dropped into a well. And so we're trying to find out what is the vertex of this graph. Well, the vertex is right here. You can imagine the other side of the parabola going downwards. So Part A, the vertex is 0, 0. Part B, it says, what does this point 2, negative 64 represent? Well, use the words that are here. The x value is time in seconds. This right here is the height in feet. So right here, in 2 seconds, what is it that's happening? This rock, so the rock is 64 feet below, is 64 feet below, or you can say at the bottom at the well. At the bottom of the well. And then Part C asks you to find what is the equation of this graph here. Well, to find the equation of the graph, and if the vertex is at 0, 0, the standard form is y equals ax squared because the vertex is at 0, 0. So the only thing to complete this equation is to solve for a. So we have a coordinate. They actually gave us coordinate 2, negative 64. This will give us the x value and the y value that we can plug into this equation so we can solve for what this x or this a value will be. So what is y? Y is negative 64. We're solving for a. X is 2, so we're going to square that. And so 2 squared is 4. You usually write the number in front of the variable. And then we're just going to take this and divide by 4 to figure out what a is. So 4 goes into negative 64, negative 16. So that is our a. So we're ready to write the equation. Y equals, we found a, which is negative 16. And then we have our value. And You could use t. I'll just write it with x first, x squared. But you can write this whole thing in the form with the h and t, because they do say time in seconds and height in feet. So you could write it as this way, or you can write the height, which is really your y value, right, equals negative 16, and then x is really your time squared. So either way, but this is the standard form. All right, number 5 says, given the parent function and the transform function, we're going to write down all the transformations that's necessary to go from this equation to this equation. All right, so let's list out all of those transformations. First things first, we have to talk about what does that negative do. And a negative reflects across the x-axis. And then there's a negative 2 right there. And the negative 2 makes it so that we have a vertical and its stretch if it's greater than 1. Vertical stretch by a factor of 2. So those are just dealing with the a value here. Then right here we have a minus 1. So think of opposite of minus 1, positive 1 means we're going to go to the right 1. And then the plus 3 moves it up 3. All right, let's take a look at this next problem. So the next problem is asking, what is the vertex of this equation? So for number 6, remember that it's just opposite same. So the opposite of positive 8 is negative 8, and then the same exact number 1. All right, number 7, what is the axis of symmetry and vertex of this equation? This is not in vertex form, so you cannot do opposite same. You actually need to use a formula. So for number 7, if you don't remember the formula, x equals negative b over 2a. That gets you the x value, the vertex, and the axis of symmetry. So looking at this right here, we have x equals, and then the opposite of b. b is negative 8. So the opposite of negative 8 is positive 8, divided by 2 times a, which is 2. So 8 divided by 4 gets us 2 for the x value. And so you can say the answer for part A, sorry, I'm going to move this up. So the answer for part A is x equals 2. All right, and then we're going to solve for the vertex, so we have to solve for the y value. So again, negative b over 2a, or opposite of b over 2a, however you look at it. This is the same thing, 8 divided by 2 times 2, which will get us 2 for the x value of the vertex, but we need to solve for y. So to solve for y, we're going to plug in the 2 back into this equation so we can solve for it. Remember, f of x is the same thing as y. So y equals 2 times, plug in the 2 into that x squared, minus 8 times 2 plus 12. All right, let's go ahead and simplify. Do exponents first. 2 squared is 4, and then you multiply, and 2 times 4 is 8, minus 16 plus 12. And then simplifying that gets you negative 8 plus 12, which is 4. So part B, the vertex is 2 for the x value, 4 for the y. 2, 4. All right. And then what is the range of this function? So in order to find the range of this function, first what we have to do is we have to find out what does this kind of look like. In your head, if you can visualize it, it'll definitely help you out. So I noticed that there's a negative in front of there, so I know this parabola is going to go downwards. I'm not plotting it completely out, I just know it goes down. This gives me the vertex, which I know the vertex is going to be positive 6 opposite, and then same, negative 2. Since we're looking at the range, we're looking at the y value. So what is the y value in this coordinate? Negative 2. And since the graph is going down on and on forever, it starts at negative infinity, and then it goes all the way up until it hits negative 2. And that's the range. This next one here, use the table to write a quadratic function. So in order to do this, you need to first figure out what is the vertex and what is another point we can use. So I went ahead and circled this. Notice that the vertex is the value that's going to be the same thing, well, I should say it's the number in the middle, and notice that the y values are the same going out. So you can identify the vertex just by looking at that number being the number that's not symmetric. Everything else is symmetric after that. And then you could just pick any other point. So on number 9, we're going to write this in vertex form. So if you don't remember the vertex form, that's y equals a x minus h squared plus k. The vertex gives us the hk, so I can plug that in right away. Y equals a, x in the vertex is -1, so keep in mind you write opposite, so it'll be plus 1 squared, and then k is going to be this -9. So that's just plugging in the vertex. Now I have to pick any point I want, and it's going to be the same answer no matter what point you pick. I like using the number 0 because sometimes it just cancels out numbers. So I'm going to go ahead and plug in the 0, -8 in for x and y, so I can solve for a. That'll complete my equation. So -8 is your y value, equals a is what I'm solving for, x is 0, plus 1 squared minus 9. At that point right there, I'm going to go ahead and simplify in here. So I have a times, and then 0 plus 1 is 1, 1 squared is 1. And a times 1 is really just a. So all I'm going to do is I'm just going to add my 9. And notice that a is going to just be 1. So when I plug 1 back in here to this equation, 1 times anything is itself. So I don't necessarily need a 1. When there's nothing here, it's automatically known to be a 1. So really I'm just going to rewrite this equation, and a is 1, so I'm not going to even write the 1. It's just x plus 1 squared minus 9.